Okay, so yesterday everything we did was like a nice pretty square root or cube root. So like if I give you the square root of 4, what would you say that is? 2. Okay. So what happens is today things are not going to be pretty. Nice pretty square root. What's going to happen is, like for number 1, you're going to get something like this. Square root of 28. Square root of 28. So when you're looking at these, because we're doing square root, I specifically am going to look at these numbers. Okay, I don't care right now about these. I want to look at these over here. 4, 9, 16, 25, 36. And I'm going to say, well, which of these perfect squares, when I say perfect squares, I'm talking about the ones that are underlined. Which of these perfect squares goes into 28? 4. 4 times what? 7. 7. 4 times 7. Okay, so what I'm going to do is I'm going to rewrite 28 as square root of 4 times 7. Yeah, we're just going to break each one down. Okay, so what is the square root of 4? 2. So that's going to come outside the radical. Do I know the square root of 7? No, so it stays inside the radical. And that's the answer. Now here's what's nice about this. You can check your answer. You can't get from here to here with the calculator, but you can check and make sure it's right. Put in square root of 28. Mine will look a little different than yours. You get some ugly, weird decimal. Colin, stop. And then put in your answer, 2 square root of 7. If you get the same ugly, weird decimal, oh, it's so dark. There you go. If you get the same ugly, weird decimal, then you know that it's right. Okay, so use that to your advantage and check your answers. Because mine's an older calculator. I will get a new one so you can see what.
Is this the part where we can't use the calculator?
No, that's tomorrow.
Why?
Yes, I told you already. You can just plug it in your
So
calculator.
that quiz Thursday?
Yeah.
Friday? I'm going to need to take it Thursday.
Okay.
I'm not going to be here Friday.
Yeah, I need to take it Thursday too.
Okay, number 2. Let's try another one. I think my next one is 48. Square root of 48. Now, what I want you to do, I want you to take 48, I want you to make your factor chart like we did in the last chapter. It's nothing to do with factoring, but I want you to make your factor chart. And I'm going to show you why. I'm going to do it up here so you can see a little bit. 48. Start with the lowest one. 1 times 48. 2 times what? 24. 3 times?
Nothing.
16.
16. Look, so far, is there a perfect square here? No. Here? No. Here?
No.
Yes.
Yeah.
Okay, so what happens is if you take 48 and you're like, oh, well, I know 4 goes in. Okay, 4 times what is 48? 12. You could do, I could split it out to be 4 times 12. The problem is you're going to have to do more work if you do this. If you do your factor chart, it's going to give you the biggest one and you're going to see it. So this is what I'm going to use to split up 48. Yeah, square root of 3 times 16, yes. Well, then you take, no, not 16 on the outside. What's the square root of 16?
4.
Yeah.
4.
Yes. So I write 3 times 16. The square root of 16 is 4. So that moves on the outside. So 4 square root of 3. Okay, and let's check it. Square root of 48, and then 4 square root of 3. So same exact weird ugly decimal, so you're good to go. Okay, next one. So now I'm going to put a number in front. 5 times the square root of 72. Okay, so what I'm going to do is I'm going to take 72 and make my factor chart like I talked about with 48. Okay, if you make a factor chart, you're guaranteed to find the first or the biggest perfect square, which will save you time in the end. So 1 times 72. Does 2 go in? Yeah, 2 times 36. Do I have a perfect square yet? Yes, I do. Wait. You can do 9 times 8, but if you do this, you're going to get the biggest one. You're going to get 36. Okay, so now I'm going to split this up. I have 5, and then inside here, 2 times 36. What's the square root of 36? 6. What do you think I do with it out here? You multiply it, yes. I'm going to write it so you have it here. 5 times 6. And the 2 stays on the inside. So what's my final answer?
30.
Perfect. And so then double check that. Can you see that? No. 5 square root 72. And then 30 square root 2. So we're good to go. So far so good? Yes. No. I'm lost. I need help. Oh, okay. You're alive. Okay, number 4, negative 3 square root 192. So you don't worry about the negative 3 right now. You just look at the 192. Right now, move. I already told you don't sit there, so move over here. Take 192 and make your factor chart. Start with 1. 1 times 192. 2 times what? As soon as you hit a perfect square, you can stop and go ahead and simplify. So you're looking for, once you make like your factor chart here, like neither of these are on my list. Neither of these are on my list. But as soon as I got to 16, I had a perfect square.
What side is on?
60.
It doesn't matter what side it's on. Yeah, not 62. 64 times what?
3.
Yes. So if you were doing this, 1 times 192, 2 times 96, 3 times 64, as soon as I hit 64, there's my perfect square. So negative 3, and then I go 3 times 64. What's the square root of 64? 8. So I bring that on the outside. Okay.
Negative 24.
Yes.
Oh, snap.
Perfect. Okay, who did I lose? Go for it. Yep.
So then basically, well, if you make it a 4, it's 4.
Not necessarily. You mean when you make, if you went to 4 here, like 4 times a year? 4 times something? I don't know, what is 4 times?
No, but you said it doesn't matter what side the door is.
Oh, right. No. I just always go over, I start here and I start with my smallest number. 1 times 192. Then I go to 2. 2 goes in. Then I go to 3. 3 goes in. But yeah, you can switch these. That doesn't matter. I swear.
Okay. You see how 64 is the perfect square?
Yes.
Okay. Well, what if the 4 was on the other side? Where it says 1, 2, 3.
Right here, 1, 2, 3.
If you go to 4,
Yes.
64 is a perfect square.
Oh, yes.
And then you told me it doesn't matter what side it's on. As long as you make it a 4, you get a perfect square, right?
So this would be,
You get it?
yes. This would be 4. Okay, let me hang on. Let me show you. Guys, let me show you something, because I see what you're asking. It's a good question. Oh, now it shows that. Whatever. Okay, so look, if I had gone, guys, look, pay attention. If I had gone here and I didn't realize that 64 was a perfect square, and I had gone here and I said, oh, well, 4 times 48. Okay, so then I take those and I go negative 3 square root 4 times 48. What's the square root of 4? 2. So I bring that out, and now I get negative 6 square root 48. Okay, the problem is, sorry about that green. The problem is it's not all the way reduced. Because 48, I can keep going with 48. Okay, so really, if you could keep going, let's see, 48 would be
2 and 24.
2 and 24, 3 and 16, 4 and 12. So again, you could pick this one or this one. So that's why when I do my factor tree, if I pick the biggest perfect square, the 64 instead of the 4, it saves you a lot more work. It's not all the way simplified. So that's a good question. I see what you're saying now. Okay. Number 5. Tyler, can you go pick up the eraser and erase that green spot? Thank you. Okay, so the first 4 that we've done were all squares. Now I'm doing a cube root. The only difference is I'm going to look at a different list. Yeah, you'll have all these lists. Okay, so instead of looking at my squares, I'm going to look at my cubes, which is nice because you have way less. Look how many are up there. You have 4 compared to your squares. You have quite a few squares. Okay, so if you list your factors of 32, 1 times 32, what else? 1 times 32, 2 times 16, 3 doesn't go in. Does 4 go in?
4 times 8.
Okay, so here's where it gets tricky because a lot of people will forget that we're doing cube root, and you'll say, oh, well, 16 is a perfect square. I'm not doing a square root, though. I'm doing a cube root. So I need this one right here. I need this 8. Okay, so I split it apart. 4 times 8. What is the cube root of 8? 2. So 2 goes on the outside. Cube root of 4 stays on the inside. Yes, I will give you the numbers. Okay, can I check this to see if it's right?
Yeah.
Yes, do you remember where, say it again? Dakota?
Where'd you get 2 from?
Right here. 2 to the 3rd equals 8. So then because I saw 8 here, I knew it was a perfect cube, and so the cube root of 8 is just 2.
And you don't have to multiply them like you do on the cube?
Well, okay, so the little 3, you don't touch. If I had another number, like I'm going to do a number in a second, like this, 2 cube root of 54. So this will get multiplied. This doesn't get multiplied. It's just like telling you what the root is.
Oh, okay.
So see right here, there's no number.
So like on the test, say it has like square root of 54, it has like a little 3 there, so you gotta cube it?
Yes.
Alright, cool.
Okay, so let's do another cube one. Number 2. Sorry, number 6. 2 cube root of 54. So I take 54 and I want to do my factor chart. 1 times 54. Does 2 go in? 2 times 27. Do I have a perfect cube yet? Yes, I do. I have 27. Come back up here, right here. So I go 2 cube roots of 2 times 27. What is the cube root of 27? 3. So I pull that out here. So what's on the outside? 6. And what's on the inside? 2. Okay, how do we feel about the numbers? Because we're about to move to the letters.
Oh, yeah. Oh, yeah.
Okay, we feel good about the numbers? Okay, so yesterday, if I gave you square root of x to the 10th, what is the little root number?
2.
A 2. What did we do with these 2 numbers? We divided them. So I would do 10 divided by 2, which gave me x to the 5th. So all the changes today, instead of it being a nice even number, it's going to just be not so pretty. So number 7, let's do square root of x to the 15th. Square root of x to the 15th. If it was a cube root, yes, because 15 divided by 3.
5.
What's my root right here? 2. Does 15 divide by 2 evenly? No. So here's what you do. Let's make it something it does divide evenly. If I take my square root, and since this is even, I want to split this up into an even number. So I go to the one right underneath it. What's left over? 1x. Okay, I'm going to keep that 2 there. Can I divide 14 divided by 2? Yes, I get 7, so I put x7 on the outside. Can I do 1 divided by 2? No, so that stays on the inside of the square root. It's the exact same thing we were doing with the numbers, like when we had a 4 and a 7. The 2 can come out, the 7 stays under. Same thing with this. If you can divide it, it can come out. If not, it stays underneath. Okay, let's try another letter one. Number 8. Square root x to the 5th, y to the 8th. Can I divide the x's evenly? Yes or no? What's my root? 2. Can I divide it evenly? No, I can't. So let's split it up. So I have a square root. If I take this, what do I want to split that up into?
4.
Good. 4, and then I have 1 left over. Can my y's divide evenly? Yes. So I'm just going to leave them for a second, or you can move it out, whichever way you want to do it. So if I divide this one, x to the 4th, what comes on the outside? X squared. Good. If I divide the y, what comes on the outside? Y to the 4th. And what's left on the inside? Good, just square root of x. So these are tricky because you can't check them in your calculator. So that's why you just need practice on the letter ones. They're not horrible. Okay, I just have 2 more for you. Number 9, cube root of a to the 3rd, b to the 8th. Just 2 more, guys. Right, so instead of just splitting it in half, dividing it by 2, I'm just dividing it by 3. So it doesn't really change a ton. Does this one divide evenly, my A? Yeah. How about my B? No. So what can I split that B into? Good. B6, and what's left over? 2. Good job, guys. So when I bring the A out, what do I get?
1.
Right, A1. If you want to put the 1, you can. You don't have to. If you take the B out, what do you get? B2. And what's left on the inside? B2. Okay, last one. So the only other types are now they'll put the numbers and the letters together. Okay, numbers and letters together. It's no different. You just do it the same way. So let's start, yeah. So if there's nothing there, it's a square root. So let's put the 2 there if you want. Let's start with the 50. What can I break 50 up into?
25 and 2.
1 and 50, 25 and 2, or 2 and 25. There's my perfect square. Okay, so I'm going to start breaking this up. I have 2 times 25. For my x's, x3 does not divide with the 2, so what do I split that up to? X squared times x. Right, and then you can leave the y. That's what everyone's been saying. I'm like, really? I mean, maybe, I don't know. Okay, so what can come out?
No, it's not easier.
Right. The 5 comes out. What about the x, 2? X. And how about the y4? Y2. Good. And what's left on the inside?
X, Y squared.
Whoa, hang on.
Wait. It's just X.
There's something else. There we go. So what I do is once I bring it out, like look, I've double underlined everything I took out, and then the leftovers are the 2 and the x.
I know the rest.